Reality is a projection of higher consciousness, and I'm not the one saying it. It's Donald Hoffman. He's a professor at Irvine University in California. He created the theory of conscious agents. His ideas are very new and powerful. Using physics, neuroscience, and cognitive science, he shows that reality is not something outside of us. We create it. He says we are not just a body and a mind. We are a piece of the infinite power behind everything. He calls it consciousness. Science is now going through a big change. This interview helps us understand it. Take time to watch and save this video, and feel free to share your thoughts in the comments. The interview is available in English and French. Welcome to the Super Sapiens channel and enjoy listening.
Donald Hoffman, welcome. We are in Tucson, Arizona for the 30th Congress about the Science of Consciousness. Thank you so much for being here with me today, and it's a great honor to have you.
Thank you, Sarah. It's great to be here, and thank you for inviting me.
You are a professor of cognitive science at the University of California, Irvine.
Yes.
You are also an author of over than 120 scientific papers and 4 books, including The Case Against Reality.
Yes.
You have developed a new theory of consciousness that is completely changing our perception of the world and putting us into a new scientific paradigm. Before getting into your theory and the definition of consciousness, can you tell me what is the current scientific paradigm we are in? What is our current perception of the world, space, time, life, consciousness, and reality?
Well, for those of my colleagues who are scientists who are studying consciousness, the dominant view is that space and time is fundamental. Physical objects inside space and time are part of fundamental reality.
What does mean fundamental reality?
That means that it's the starting point for any of our scientific theories. This is what we assume is the beginning point for any explanations we're going to give. So the beginning point for the scientific explanations are physical objects inside space and time, not consciousness. So the beginning point is not consciousness. They view consciousness as something that came very late in the history of the universe. So but I would say most of my colleagues who study consciousness are studying it from a point of view in which consciousness isn't fundamental. It's created, for example, by brain processes and maybe by other processes. Maybe an artificial intelligence program could create consciousness. So that's the dominant view. Now, given that it's the dominant view, you might say, well, they must have some good success to show for what they've been doing. And what's remarkable is if you look at all the conscious experiences that they're out there, and there's the taste of chocolate, the smell of garlic, feeling of a headache, color yellow, and so forth. There's all sorts of tastes, smells, bodily sensations. So how many experiences can they actually explain with their scientific theories? And the answer is 0. There are 0 specific conscious experiences that the physicalist scientific theories can explain. So even though that's the dominant view, there's some trepidation in the field because it's not going so well in terms of actually explaining specific conscious experiences. So that's the way most people are thinking about things. They recognize that there's a problem, but they still assume that the right physical or functional. There's the physicalists, and then there are functionalists who think that it's just something more algorithmic that's critical to creating consciousness. And even the functionalists have no successes on specific conscious experiences. There's no specific experience like the taste of salt that they can explain. So that's where the field is. They assume that consciousness arises from physical stuff, and physical stuff is fundamental, but they don't have any successes on any specific conscious experiences.
Yeah. Mm-hmm. How is it important to understand that to explain conscious experiences in the realm of science?
It's now one of the big, I would say, open problems. 30 or 40 years ago, it wasn't considered respectable for scientists to really focus their attention on it. But since the early 1990s, and partly because Francis Crick said we need to solve this problem, and a lot of people say, well, Mr. DNA is saying we need to study this problem. So people started to jump in and really look at it seriously. And it's turned out to be a lot harder than people thought. They thought that we might be able to knock this off in a few years, and they haven't knocked off a single specific conscious experience. And so that hasn't changed the paradigm yet. The paradigm is still somehow brain activity causes conscious experiences. And they're still working on that. And of course, it's leading to all sorts of good neuroscience, so it's not wasted, but I think it's the wrong direction to actually understand consciousness. It's great to understand neuroscience for its own sake, but it won't help you understand consciousness.
But this paradigm is also, it tells us also that life is created from matter. It's what you were telling about space-time and objects and reality. We are not talking only about consciousness, but also life appearing from matter.
Yes, that is also the dominant view, which is that the universe began in a Big Bang 13.8 billion years ago, and there was only inanimate matter and energy at the Big Bang, but somehow over millions or billions of years it coalesced into complex forms that somehow, in ways we don't really understand now, got the ability to replicate. And that was the starting point of what we now call life. But again, they don't know how non-reproducing chemical systems somehow got the magic of reproduction, which was critical for the evolutionary Darwinian process then kick in and start to do the natural selection. So once again, there's a physicalist interpretation of the origin of life, like there's a physicalist interpretation of the origin of consciousness. And both are the dominant views. I mean, 99% of the scientists, the genuine scientists in the field, not people just talk about it, but the ones who are really doing research, are physicalists in both, I would say, in both fields, science of life and consciousness. But again, they see that there are these tensions. There are things they can't explain yet.
Mm-hmm. When we talk about consciousness, are there different definitions, like a state of consciousness, a subjective experience, the sensation of being a self, awareness, sentience? What is consciousness?
Right. So there are lots of things that people could be referring to when you talk about consciousness. As you mentioned, it could be anything from sentience to self. So when I talk about conscious experiences and consciousness, I'm saying things like having the taste of salt, or hearing the sound of a flute, or smelling garlic, or something like that, seeing the color red. Those are what sometimes they call qualia, which are specific conscious experiences. The problem comes right there. You don't need to go to the issue of like a self, which might sound even more complicated. We don't have to go to something complicated like the self. Just how do we get a scientific theory of my experience of the color red when I see a red tomato? How do I explain that color red? We have no scientific theory that comes anywhere close to saying how neural activity could possibly create the experience of the color red, which isn't to say that we don't know what parts of the brains are active when you see red. So we know what are called neural correlates of various conscious experiences. But knowing the neural correlates is nowhere near having a theory. So we have this mystery that why should these particular neurons in area V4 of visual cortex be active when you experience colors? And we know that correlation is there in lots of different human subjects, but we know nothing about how that actual neural activity could cause my experience of the color red. We literally have no theories about it at all.
And what is your theory about? Can you explain your theory? How did you come to this conclusion, and so on?
Well, yeah. So I became quite impressed that the people in this field are my friends and my colleagues. I know many of them quite well. They're brilliant. These are not dumb people. These are really, really smart people. And this problem has not broken for them, and they've been at it for decades now. And so I began to think that maybe we're looking at it from the wrong direction. Maybe the idea that space and time and physical objects inside space and time is fundamental is the wrong idea. And so I've been looking at it, let's start from a different foundation. Let's take conscious experience itself and consciousness to be fundamental. Now, that's not new in some sense, right? Spiritual traditions have been saying that for thousands of years, that consciousness is fundamental. And traditions, both East and West, have said that. So I'm not saying anything new, but what's new is saying, let's put some mathematics to that. Let's try to make predictions, experimentally testable predictions. Let's prove that we can show how space and time arise from a theory in which consciousness is fundamental, instead of the other way around, which is what everybody assumes, that space and time are fundamental and consciousness arises. So if we're going to change the paradigm and be taken seriously in science, we have to show exactly, with mathematical precision, what we mean by consciousness. So we can't just wave our hands and say consciousness. No, you need to write down a mathematical structure for what you mean by consciousness. And then you have to show how that structure, some dynamics perhaps in the structure, gives rise to what we would call the Big Bang, and what looks like the evolution of life, and then the evolution of consciousness in that. So it's a tall order, right? And it should be. I mean, scientists have every right to be skeptical. People have talked about consciousness for thousands of years, and they've produced nothing. Mm-hmm. So what I said about the physicalists, I'll say now about the consciousness first. So physicalists have the problem that they say, oh yeah, we'll create consciousness out of physical stuff. And I say, well, show me one. And then it turns out you can't show me even one conscious experience that you can explain. So now turn the other way around. For those who say consciousness is fundamental and physical processes somehow are just projections or derived from consciousness, then of course the scientific attitude is, okay, show me one. Give me a specific physical process that you can explain that rises from consciousness. And the answer is, we have 0 of those as well. So you might say it's even Steven, right? Mm-hmm. So that my goal is to actually show that it's much easier, not to say easy, but it's much easier to start with consciousness and make predictions of physical processes. Easier in the sense that it's, I think, possible to do it, whereas I think it's actually impossible to start with physical stuff and boot up conscious experiences.
But there is something also with the physical and the matter that is going on. Like if we go too far, too close to the matter, something happens, like nothing
Yes.
Rests. There is nothing more.
That's right. So this is another piece of evidence that physicalism can't work here. And that is, the physicalist theories themselves tell us that the notion of space and space-time, Einstein's space-time, falls apart at 10 to the minus 33 centimeters, 10 to the minus 43 seconds.
Why so?
It turns out that when you try to measure things that small, right, what do you have to do? You have to get a bigger and bigger microscope to see smaller and smaller stuff, right? And what is the microscope doing? It's giving you wavelengths of light that are skinnier and skinnier wavelengths of light so that you can resolve smaller and smaller details. And that's fine. Quantum theory says you can make those wavelengths as small as you want. Now, what quantum theory also says is that as you make those wavelengths smaller, the energy required is higher. So smaller wavelengths require higher energy. And this is where the problem comes. As you try to get things with finer and finer resolution, the energy is going up, and Einstein tells us, Einstein's theory of gravity tells us that, his theory of special relativity tells us that matter and energy are the same thing. They're transforms of each other. So the energy is actually mass, and as you put more and more mass into a smaller region, space-time is curving. His theory of gravity tells you space-time is curving, and at some point it curves so much that it actually collapses into a black hole. So the problem is at 10 to the minus 33 centimeters, you're trying to measure something, and instead what you do is you create a black hole and you destroy the very thing you're trying to measure.
And what is a black hole?
So a black hole is effectively a place where once you go into it, you can't get back out. Everybody's seen movies and there are black holes and so forth. You don't want to get too close to a black hole. If you get sucked in, it's no return. And if you try harder, say, well, I'm just going to try harder and put more energy, make smaller wavelengths, the black hole just gets bigger and bigger. So there's no way around this. Space-time doesn't even mean anything anymore, so to speak.
So that does mean that the matter doesn't exist by itself? I mean, because if we go closer, there is a black hole. So the matter is not there?
Well, there are theories about what's going on the other side of the black hole wall,
Mm-hmm.
and there are lots of interesting theories. We're not for sure about what's going on there, but we think space and time reverse their roles, and then there's some interesting structure to these black holes, but it doesn't seem like you can get back out. So once you go into the black hole, you can't get back out. So from our point of view, effectively, that's where our space-time ends. And that's the current framework that we have, is that space-time is fundamental. So what this is basically saying, and now I should say, these are high-energy theoretical physicists. This is the group of physicists who do this. And they're saying that space-time can't be fundamental. They say space-time is doomed.
But can black hole be fundamental this way? Because if we go nearer, we find a black hole, or we create a black hole. So can a black hole be fundamental?
I don't think so. And none of the physicists are trying to say, I mean, at least this new brand of high-energy theoretical physicists that are saying space-time is doomed, they're not saying space-time is doomed and we'll replace it with black holes. They're saying we need to, step entirely outside of the notion of space-time and quantum theory. So black holes come out of Einstein's general relativity, but it's really, to understand them, you have to know general relativity and quantum mechanics together to understand them. What the new physics high-energy theoretical physicists are saying is that we have to let go of space-time completely and quantum theory completely as being fundamental and look for new mathematical structures entirely outside of space and time.
Why do we say that quantum theory is fundamental?
So one reason why people had thought that quantum theory is fundamental, and many physicists still do, is that Newton, for example, Newtonian physics, had certain failures. It could not explain chemistry. It just had no tools to explain what's going on in chemistry. And so quantum theory, one of the big successes of quantum theory in the late 1920s, early 1930s was that it for the first time gave us the mathematical tools to understand chemistry. And
through the particles.
Through particles. So we gave us
to make it easier.
Yeah, particles, and so elementary particles like electrons and so forth. It gave us an understanding of how they behave. For the first time, Newton couldn't do that. And of course, electrons are critical to chemistry. So when we finally understood how to think about the behavior of electrons and then other particles called protons and neutrons, then we could start to understand chemistry. We found out that protons and neutrons are not fundamental. They're made of quarks and gluons, which are more fundamental, at least in our current models. But
that's why we say that quantum theory.
That's why they thought quantum theory was fundamental, because it was doing all this stuff. But so for a while they thought quantum theory was fundamental, and many still do. But now we're realizing that space-time and quantum theory are really connected. That they come together, and so they're looking for new structures outside of space-time that will give rise to space-time and quantum theory together.
And those structures are?
Well, they have a funny new name called positive geometries. So, and they're these geometric structures completely outside of space-time. So there's no notion of dynamics or something moving. It's just there are these diamonds, if you will. So these structures sitting there, and their geometry and their volumes encode interesting information that we can use to understand how particles behave inside space and time, the probabilities of the ways they interact, what they call the scattering amplitudes. So they've discovered that when we can look outside of space-time, and they've only done this in about the last decade, in about the last 10, 12 years or so, they've looked outside of space-time. They found these positive geometries, some things called amplituhedra, cosmological polytopes, associahedra, and so forth. And they do allow us to successfully compute the probabilities of particle interactions inside space-time. They make it much simpler. What might take millions of terms and hundreds of pages of algebra to do, like 2 gluons hitting each other and 6 gluons spraying out. A real mess when you do it inside space-time with something called Feynman diagrams using standard quantum field theory. But when you do it outside of space-time with these new positive geometries, then all of a sudden the math becomes, the computation becomes much, much simpler. 4 or 5 terms that you can do by hand in some cases.
So this theory wins.
Well, it's simpler in a sense, and it shows you new symmetries. So that's why, actually, in Europe right now, the European Research Council has funded 10 million euros to study this stuff. There was the first workshop in February. They had more than 100 mathematicians and mathematical physicists who are jumping in to study these positive geometries. So it's a brand new thing. Science is now moving outside of space-time, outside of quantum theory, big time, and they're going to show how space-time and quantum theory emerge from deeper structures called positive geometries.
So scientists should follow this new findings.
Yes, yes.
So it's what you did, actually, to follow this new perspective. And also, through your work, you've studied our perception of reality. So can you tell us more about the reality as we perceive it, and your book, actually, which is the case against reality, and how it is related to consciousness and your theory?
Yes, so there are two problems here. One problem is the relationship of consciousness to the physical world that we've been talking about. But there is another interesting question, which is the relationship of our perceptions to whatever objective reality might be. And do our perceptions tell us the truth or some truths about the way the world really is, or not? So those are two separate questions, although we'll see that they have connections later on. So most people intuitively feel that we don't see all of the truth when we look around, but we see some truth. I look and I see an apple sitting on a table. That's because there really is an apple and there really is a table, and I'm seeing the truth. And anybody who thought otherwise is probably crazy. But as we study human perception from a scientific point of view, study of psychophysics as well as Bayesian models of perception, we actually try to build computer vision systems. Right? We're trying to get self-driving cars. Well, part of that would be what are called passive vision systems, where you try to put video cameras on a car, bring video feed in, have a computer process it to see what's out there, and to make sure you don't crash into pedestrians and fire hydrants and so forth. So in the last 30 or 40 years, we've really started to actually not just wave our hands about like vision, but we're trying to build vision systems. We're actually trying to build systems that can drive cars and eventually put eyes in robots so robots can. So we can't wave our hands, we have to build stuff. And what do we find when we're doing that? Well, what we find is that the camera is just giving you data like at this pixel, it's this bright. And at the next door pixel, it's that bright, or it's this color. So all you're getting is, maybe it's 1,000 arrays of 1,000 dots. So you have 1,000,000 dots, 1,000 by 1,000, and at each dot you just have a color or a brightness. That's all you have. You don't have objects. You don't have like tables and chairs and apples and so forth. You just have numbers which tell you the color. So what you have to do then is have really sophisticated software to do that. So the idea then is our eyes don't see the truth. They just get brightnesses. The eye is registering brightnesses. You have to then make an interpretation of the world. Create your own version of the world that best explains the light that's at your eye or at a camera, at a video camera. So what we find is you're constructing what you see. But now most would say, well, yeah, you're constructing what you see, but if it's done right, what you construct matches what was really out there in the first place. So you are constructing, but it's really a reconstruction of what's already out there. So that's the standard view of most of my colleagues. In most normal cases, yeah, you are constructing, of course you're constructing, but we're lucky it's a reconstruction. Evolution shaped us to have a reconstruction of the world, because the idea is that evolution wants us to be more fit, and surely seeing the truth, or at least the truth that you need, is going to make you more fit. So that's the point of view that most have. Well, so I looked into this with some graduate students and colleagues. Justin Mark and Brian Marion were my graduate students, and Chetan Prakash and others work with me, and Manish Singh. And what we found was surprising. In part, evolution does try to do things fast and cheap, right? If it takes you 5 hours to compute that there's a lion, that's not going to be very, very good. I mean, the lion will eat you before you figured out that it's a lion. So you can't do things perfectly. You need to do things fast, and you need to do them fairly cheap, because the more calories that you spend on perception, the more things you have to go out and kill and eat to get those calories. So there are selection pressures to do things fast and cheaply. And many evolutionary theorists, including Steven Pinker, have understood that for a long time. In his book, How the Mind Works, he was very, very clear that there would be selection pressures against veridical beliefs, against true beliefs and even some true perceptions. But even Steven Pinker thought that everyday middle-sized objects like an apple on top of a desk, we're probably right most of the time, pretty close to the truth on those. So that was what I went after. Is it true, according to evolutionary theory, that there's a high probability that we're seeing reality as it is, at least for those middle-sized objects? And what we found was quite the opposite. We found out that the probability is precisely zero. The probability is zero that any of our perceptions have been shaped by natural selection to show us any aspect of objective reality, truly. And I should be careful now about what I'm saying. I'm not saying it's a fact that we don't see reality as it is. I'm saying evolutionary theory tells us that according to evolutionary theory, the probability is zero that any organism has ever been shaped to see any aspect of objective reality truly. So for most of my colleagues, that's pretty remarkable because evolution by natural selection is our strongest model of the evolution of sensory systems. So what I'm saying is, as a scientist, I'm looking at our best model of how sensory systems evolved, and that model unequivocally is telling us you don't see the truth. With probability 1, you don't see the truth. So what do you see? Right? And the way I like to think about it is that evolution sort of gave us a headset. So if you're playing a video game, but a virtual reality kind of video game, multiplayer, where you get to be immersed, you put on a headset and you're seeing a 3D world and so forth. Say it's like Grand Theft Auto or some game like that. Well, what you're really doing in this analogy is there's some supercomputer somewhere that you can't see, and you're toggling millions of bits in a precise order very, very quickly in that supercomputer. That's what you're really doing. Is that what you see? No, you wouldn't play the game. It's no fun, and it would be too hard. What you see is a steering wheel and a dashboard and or someone else's red Ferrari that you're racing. You see your gas pedal, and you see an avatar of your own hands holding the steering wheel.
Something fancy.
Something fancy that helps you play the game, and that's the point. You see a steering wheel and a gas pedal and a brake pedal. That helps you play and win or lose, but hopefully win in this game.
The game of life.
That's right. So in the virtual reality, it's to win the virtual reality game, but what evolution did was shape us with a virtual reality headset that we call space and time and physical objects, which is our virtual world to hide the truly nasty truth. Whatever the truth is much, much more complicated. So what we have is evolution shaped us to be able to succeed at the game of life, and to do that, it meant you can't see the truth because toggling bits is much, much slower and more error-prone. Someone who has to toggle bits will never win the VR game. So evolution has shaped us not to see the truth, but it gives us a user interface, if you will, that helps us to control reality without knowing what reality is. So that's a real shock to the system, but that's what our best science evolution tells us.
So could it be that reality would be made of bits and informations?
Well, there are some theorists who say that, right? There are some who would like to say that the fundamental nature of reality maybe isn't just space and time, then it's some kind of bits. And there are the simulation theories. So there are simulation theorists like Nick Bostrom and others who take that point of view. But so they'll say that, yeah, you and I and the room here and so forth, this is not really the truth. This is just a simulation. There's some programmer in another world that has programmed up this, and it is just a bunch of bits in their computer, and that's all we are. And that programmer and their computer, as it turns out, may also just be a simulation from yet a deeper level programmer and their computer. And so there could be lots of different levels of simulation. Most of these simulation theorists say that at the bottom there's some programmer in a real physical world. So they don't get rid of physicalism. They still say that in some sense there is a space-time world, but they want to say that in some sense, what we call our human consciousness and our experiences is just a functional property of these bits. So this is the functionalist point of view. It's also in a physical framework, but the functionalist would say, look, functionalism, we don't really care what the medium is that carries out the function. It's the function itself that's really critical, that leads to, say, consciousness or conscious experiences. So that's what they would say in this kind of approach. But I would again say, as I said earlier, it's not just that physicalist theories have explained zero conscious experiences. Functionalist theories have explained zero conscious experiences. So they say that we can do it, but they haven't done it on even one specific conscious experience.
So we put this aside.
Okay.
Reality can be made of bits and information.
Right.
There is something else.
Yes.
What else?
Right. And the reason I put it aside is, well, partly no one has any idea how to make it work, and all the attempts so far have failed. There's not a single success on any specific conscious experience. So where do we go from here? What are we going to do? So all of the theories have been assuming space and time and physical objects and perhaps functional properties. And they're saying, if you grant us that, then we'll try to explain these conscious experiences. But they can't explain the conscious experiences. They also have to stipulate them. So they're stipulating, that is, they're assuming space and time and physical objects and bits and functions, and then they're having to assume the conscious experiences because they're not explaining them. So what I've proposed is, let's start the other direction. Let's just start with the conscious experiences and only stipulate the conscious experiences and have a mathematical model of conscious experiences as fundamental. And then we will have to do the opposite direction. We'll have to show how what we call space and time and physical processes inside space and time arise from a model that doesn't care about space and time. It's just conscious experiences. And so that's the approach that I'm working on right now, is consciousness is fundamental.
So the name of the theory is conscious agents.
That's right, yeah. So working with Chetan Prakash and Robert Prentner and Swapun Chattopadhyay and others, graduate students, working on a theory in which we have these mathematically defined entities we call conscious agents. For those who know the mathematics, it's Markovian dynamics on probability spaces. That's the mathematics that we're using. And what we're doing is first analyzing that and seeing if it provides an adequate model of consciousness that would allow us to explain a lot of consciousness-related phenomena. The only thing we assume is that there are experiences, like taste of chocolate, the smell of garlic, color red, and so forth, and that these experiences can interact probabilistically. If I see red now, there might be a probability that I'll see green next or blue next. So that's all I'm assuming in the theory, that there are experiences and probabilistic relationships among experiences of these agents. And then we have to show how space and time emerge from that and make specific predictions.
So Markovian dynamics are the way that a probability is made out of the last event. Is this something like this? All the interactions are made in the now.
Yes.
And the next event depends on the now, but not necessarily from the previous events. Something like that?
That's right. So yeah, the Markovian dynamics basically says that it tells you the probability, if I'm having this particular experience now, what will I then experience next? And it's giving you all those probabilities, and it puts them in what we call a matrix, if you will, of numbers. And that matrix then can also be viewed as an operator. It can actually can be viewed as something that does something. And so we're using that operator kind of interpretation. But it is all about the now. And some people might say, well, that's Markovian dynamics are very special. The only memory they have is the current state. And so maybe this isn't a big enough or general enough model. My attitude toward it is you can make the content of the now as rich as you want, as big as you want. So you can, in fact, make the states as very big as you want. So the only real constraint is Markovian dynamics depend on a finite amount of data, but that finite amount of data from the past can be as much as you want. You need 10 billion bits? We can make a Markovian dynamics with 10 billion bits. You need 1 trillion bits? We can do that. Whatever number you want to name, we can do a Markovian dynamics for it. So for any practical purposes, there is no problem that a Markovian dynamical system can't model for anything that you really want to do. So I guess one thing would be just how is it related to physics? I mean, people might say, is this just an airy-fairy theory of consciousness? Why should we take it seriously at all, right? So a theory of consciousness has a lot that has to do, right? It has to explain learning, memory, problem-solving, intelligence, the self. It's assuming conscious experiences. So it's not explaining that there are conscious experiences, it's assuming that there are conscious experiences, but it needs to be able to explain relationships among conscious experiences as well. And then most importantly, I think, for scientists, it needs to show where space and time come from, and it needs to predict something like, if you really want me to believe this, predict the momentum distribution of quarks and gluons inside the proton at all Bjork and X and Q squared that we've studied in colliders, as they should be. Scientists are going to be very hard-nosed and say, if you think consciousness is fundamental, then prove it. Make some prediction or show that you can actually model what we already know about the momentum distributions of quarks and gluons inside protons, for example. There's many things. How about the interaction between photons and electrons, or whatever it is? You need to be able to explain some physical processes and get the numbers right. We know these numbers to 10 decimal places. How many decimal places can you get? So that's the kind of hard-nosed attitude that a theory of consciousness, being first, should have to face, right? No hand wave. You think consciousness gives rise to space and time. Prove it. We know the answers to 8 decimal places. How many decimal places can you get? So I'm completely on board. I agree that hard-nosed attitude should be applied. So I should first say our theory is not yet making predictions on the decimal places. So we're working towards it. And people can look at our papers and see how close we are to it. And I'll explain where we are on this. But that is my goal, is to make strong predictions.
And are there things like gravity or other, specific physical mysteries that eventually your theory could explain?
That's right. If our theory is to be taken seriously, it will have to show how Einstein's theory of gravity appears. We'll have to, of course, understand his special theory of relativity as well. We'll have to show how quantum theory arises from it. And we'll have to predict all sorts of things, or explain like something called the fine structure constant in physics, which is the coupling strength of electrons and photons together. So there's all sorts of things that we'll have to explain, and we're working on that.
Is there some explanation you already have about, I don't know, the speed of light?
That's right, yeah. For any theory that wants to say that it's a new, deeper theory needs to do more than the original theory. So Einstein's theory of space-time assumes that the speed of light is the same for all observers, and that nothing can go faster than the speed of light. So, and that's pretty surprising, right? I mean, that's a weird world that we live in, that nothing can go faster. There's a speed limit. It's 300,000 kilometers per second. And the speed of light is the same for you no matter how fast you go. It still looks like the same speed. So Einstein doesn't explain that. He assumed that, right? If we're going to have a deeper theory than Einstein's space-time, one thing you'd like it to do would be to explain why within space-time the speed of light is a maximum speed, and why everybody sees it the same. And also it turns out that when you have no mass, if you're actually an object with no mass in space-time, then you have to move at the speed of light. Right? That's another thing that we discover in Einstein's theory. You have to move at the speed of light if you have no mass. You have no other option. That's if you're a particle. So in our theory, we have the first hints of an explanation of that. It's a long story, but I can say a little bit about the story. The first part of the story is going back to these positive geometries that the high-energy theoretical physicists have found. They found these geometries. They're these geometric objects outside of space-time. They're static. They're not moving. They're just sitting there. And they have a structure that can be described by other objects called decorated permutations. These are combinatorial objects that can be used to describe and classify these objects. And so what we have done is this. We have a theory of conscious agents and their interactions, And we said, can we first map our theory onto the decorated permutations that the physicists have found, the high-energy theoretical physicists have found outside of space-time? And that we've done. So we published that in 2023. And what we show is the very same mathematical structure of decorated permutations that the physicists use to, in many cases, tell them everything they need to know about particles in space-time to predict their probabilities of scattering. So for massless spin-1 particles, I believe the decorated permutations give you pretty much everything you need to actually predict the scattering amplitudes inside space-time of those particles. So what we were able to do was to show how our Markovian dynamics of conscious agents maps onto these decorated permutations. And when we did that, what we discovered then was what part of our Markovian dynamics would be projecting into particles. So particles are a projection of what aspect of the Markov dynamics of consciousness. And we found what it told us was look at what these things called recurrent communicating classes. So these are special parts of these Markov kernels, the special groups of cells that sort of are coherent together. You can get from one state to another state and back. From any state within the cell, you can get from one to the other and back with a positive probability. So in other words, in some sense, they all interact with each other. That's what it means. So you get a bunch of states that are all in some sense interacting. Then you might have a group over here that interact. And so there'll be like little cliques, little groups that these talk to each other, and maybe these don't talk at all, or they talk just very, very little. And so what it told us was, look at these so-called recurrent communicating classes, these groups that talk, and those, in some cases, project down to what are called particles inside space-time. So then that told us, now let's look at what properties these groups of cells could have when they're recurrent communicating classes. So that led us to specific technical predictions for that the mass of a particle is a projection of something it's called the entropy rate. So it's called the entropy rate of the communicating class, and that the distances in space and time are projections of the commuting times of these cells. And those two predictions, and there's others. Spin is a projection of the determinant of the matrix and things like that. But the two that I mentioned, that the mass is a projection of the entropy rate of the cells, and that the distances between states distance in space-time is the commuting time between the states. Those two themselves then tell us that, yeah, there will be a maximum speed in the projection, and that, in fact, the massless objects, the zero entropy rate ones, are the ones that have the fastest commuting times. So we actually see already that just by getting the bridge from our conscious agent theory to the decorated permutations, it told us where to look, and then the only correspondences we could make were between entropy rate and mass, for example, and commuting times and distance. And when we do that, then we'll all of a sudden look at it and go, well, that explains why the speed of light is universal and why you have to be going at the speed of light when you're massless. So it's a hint. What it does is it gives me energy to continue to follow this, right? It's quite
celebration time?
Yeah, that's right. But ultimately what we want to do is predict the precise properties of particles and their interaction probabilities and so forth. So we're not done, but I would say that the ability to explain what Einstein had to assume is pretty fun. That is pretty fun. You know, as a hard-nosed scientist myself, it's always good never to believe your theory. There's no theory of everything. This is a good model going forward, and it's worth pursuing further.
So to make something complex and technical easy, I will try to reformulate it. There are conscious agents that are communicating together and creating something that projects into space-time and
yes.
and the interface.
Yes.
Okay. I've heard that the speed of light could be actually the speed of causality.
Well, inside standard physics, like in special relativity, they will say that two things can only be causally connected if they're within a certain part of what's called a light cone. I'll put it this way. We shouldn't talk about objects, we should talk about events. If two events in space-time are separated in a way that no light signal could have gotten from one event to the other event. Then you say, for example, if I'm thinking about, I'm sitting here on Earth and there's something that could happen on the moon. And anything I do here, it takes about a second for light to get from Earth to the moon. Anything that happens on the moon during that second had no causal interaction with what I just did here, because even light couldn't get there, so no causal interactions could have taken place. So there's going to be certain events on the moon that could be causally related to me doing something here on Earth, and others that are not, that couldn't be. In special relativity, you have the notion of things that could be causally connected and those that are not. Now, that's one idea, but then the notion of what is cause itself is a very deep, what is cause and effect? I mean, that's a deep philosophical question, especially when you get into quantum theory. Now, it's all probabilistic. So now it's not really clear what you mean by cause, right? If I send a photon through a double, in a double slit experiment, there's a certain probability it'll go through the right slit and a certain probability it'll go through the left slit. If you actually don't measure, then you can't say which one it went through. So the notion of cause and effect becomes at least problematic. And there's no generally agreed upon notion of cause and effect.
But in your theory, consciousness could be the cause and the interface could be the effect.
That's right. So the idea would be that the normal way of cause and effect explanation in science, which would be physical stuff causes consciousness. My brain activity causes my conscious experience of the taste of chocolate. I'm proposing the reverse, that we start with a theory in which if there is cause, it's conscious experiences causing other conscious experiences. That's what's fundamental. And taking that model, then we would get what we call space and time and physical objects as resulting from the prior cause of conscious experiences interacting.
Because my understanding with the speed of light being the speed of causality is that the velocity of which the conscious agents interact is the speed of light, and they project at the speed of light into the interface. This is my understanding. Maybe it's awkward. You know what I mean?
Well, so there's another aspect to this in the notion of causality that's pretty important, and that is that in quantum theory, there's a notion of entanglement.
Yeah.
And so there are certain systems of objects, for example, with correlated spins, where if the spin of, maybe the spin of these two particles is zero. So if the spin of one is up, the spin of the other one has to be down. And if you put them, you send them a million light years apart, and you measure the spin of one, and you know that it's up, then you know instantly that the other one is spin down, even though it's a million light years away, so no causal connection could exist instantly.
Non-locality.
It's the issue of locality and non-locality, absolutely. So there's that kind of thing that you also have to explain. So the conscious agents theory could explain what we call entanglement inside space and time. That there is, space and time isn't the fundamental reality. There is this realm of conscious agents that's really and there could be all sorts of connections going on there that you don't see inside your space-time interface.
If the matter doesn't exist as we perceive, as we see it, my body neither. Doesn't exist really.
Right.
So it's just a perception of it.
Yes.
Who I am in this case, if it's not this body. Am I a conscious agent?
Yes. So in this theory, you would be a conscious agent, and you would also be quite a complex network of conscious agents. They can combine. Agents interact and they can combine to make bigger agents. So yes, what this theory says is very counterintuitive. Most of us think that, who am I? Obvious what I am. I weigh a certain number of kilos, 20, 50 kilos, 80 kilos, or whatever it might be.
I am identified with my body and my history.
That's right. That's what I am. So I'm a little body inside of a big space-time. That's what I'm, a little tiny physical object in a vast universe. So I'm a really small thing. And I'm turning that all around. I'm saying that you are not your body. That body that you experience is just your avatar in a headset. And that you are the fundamental consciousness that has created this headset. And so that all of what we call space and time is inside you. Instead of being the vast, huge universe in which you're a small object, that vast, huge universe is, in fact, a trivial aspect of you, a little dumbed-down interface that you create from you. But the way I think about it is that, what consciousness is doing is it's looking at itself through a perspective. Consciousness, whatever the one big consciousness is, it chooses to take a perspective and look at itself. And ours is a
different perspectives.
Different perspectives. And there's
how many possible?
Countless, many, an infinity of different perspectives. So we think that we're looking at the true universe. This is just one headset out of an infinity of different headsets. And my own view is that this is probably one of the cheaper headsets. There's only 3 dimensions of space and 1 dimension of time. Why not have 50 dimensions? Why not have 50 billion dimensions? I mean, there's no reason. So this is one of the more trivial ones. We're probably one of the dumber headsets.
Spiritual philosophies talk about the way we can transcend reality and the mind so we can access maybe the consciousness. And so what do you think about that, and how can we do that?
That's right. So most of us believe deeply that I am just this little body inside space-time. And we feel very vulnerable, and as bodies in space-time we are. But think about it this way. Suppose that you're playing, again, a video game, a virtual reality video game. It's immersive. You have a headset on, and when you put on the headset, you see your avatar inside this world. Say Grand Theft Auto again. Well, there are 2 ways that you could be with yourself in the game. One is to say, I am my avatar. So now you're completely identified with that avatar. So now, if your car crashes or someone pulls out a gun or is trying to come at you with a sword, that it's attacking you directly, right? And so you can have all sorts of fear and anxiety. It's quite a thing. But if you're playing the game and you know that avatar is not me, that's just an avatar. I can just have fun. If the avatar gets messed up, no great shakes, I'll just reboot and play some more.
So what does mean reboot in this case? I mean, what is after death? And
yeah, I can just reboot the game with another avatar, or if I have many avatars, I can just say, okay, give me another avatar. So that was in the VR game, what I meant by reboot. Now, in everyday life, what I'm saying is, in real life, we can also be the same way. We can either say, I am my body, so I'm very, very scared if something happens to that body. And I would say, and of course, we have to be careful to play the game of life.
That's why you have emotions also?
That's right. Exactly right.
To behave in a certain way?
To behave properly, that's right. People who actually can't feel pain die early. So we can identify with our bodies, in which case we're going to be full of fear and so forth. Or we can begin to realize that, no, I'm not my body. I am the consciousness that is creating this whole video game of space and time and physical objects, including what I call my body. Now, I will still feel pain if someone cuts me, but my attitude toward the whole thing is going to be different, because in some sense, what death is then is taking off of the headset. So just as when in a video game, when you take off that headset, you leave that world. So you're no longer in that Grand Theft Auto game. Nevertheless, your consciousness continues. Doesn't continue in the form it took in that game. But your consciousness still continues. So that's what I'm suggesting is happening when we die. This particular game, we no longer continue in this particular projection, this particular game, but that doesn't mean that your consciousness ceases. So that's one interesting consequence of this point of view.
And if I am the fundamental consciousness and then I create my world, what else can I create? How far can I create? How is my power of creation actually? And do I have free will to create what I want to appear in this interface?
Yes. So the mathematics that we're working on right now says that there's essentially no limit to the number of interfaces and different varieties of interfaces that could be computed. It's not just infinity, but it turns out there's more than one kind of infinity. So the guy named Gregor Cantor discovered in the late 1800s that there's not just one infinity, there's many different sizes of, there's an infinite number of infinities, each bigger than the other. And so right now the work I'm doing is only on like the first level or second level of infinity, and that's plenty for me right now. But if we're going to talk about the one consciousness, my guess is that our model is going to have to be upgraded to the whole Cantor hierarchy and beyond, which isn't going to happen this week, that's for sure. So whatever you are, so completely transcends anything that we can imagine inside this little interface. So, in other words, it's we always say you shouldn't be so egoic and selfish and think so highly of yourself, and that's certainly true when you're identifying yourself with your avatar. But when you let go of that and you ask, "What am I in reality?" then you can't think big enough. But the reason why there's no silly ego involved in it is because you realize that everybody else that you interact with is just another avatar of that very same infinite intelligence. So it's no longer me being better than you or worse than you. It's rather me recognizing that you and I are, in fact, the same infinite intelligence, just under different avatars. So in certain religious traditions, they will say that one of the fundamental rules is love your neighbor as yourself, right? And we all sort of intuitively go, that really does make sense. I mean, anybody who actually loved their neighbor as themselves is going to be a really pretty good person. What I'm saying is the reason for that rule is your neighbor is yourself. That's why you should love your neighbor as yourself, because you're in fact loving yourself just under a different avatar.
Because you say that many conscious agents form one consciousness.
That's right. Or what I might call the whole. Because it turns out we do have a mathematics that describes how agents can combine. And when we talk about the one we think about, they might combine all the way up and there's only one at the very top. And it turns out it's much more interesting than that. When you look at how the agents combine, there are infinitely many ways that they can go and get more and more combined, and it never stops. And you can go in infinitely many directions. So already my notion of what we might call God, which naively was before, maybe all these things combined, there's only one at the top. That turns out, I think, from the mathematics that we're doing with the conscious agent theory, to be far, far too simple. And there's this non-Boolean logic of combination of consciousness, which makes God infinitely more interesting and more complicated than the single little dot at the top. Right.
Okay.
Much more interesting.
Okay. So what powers do we have as being conscious agents, actually, in the real life? What is my potential as a human being?
That's a great question. First, I should eat humble pie first and say, I'm working on this theory, but I'm like everybody else. I am most of the time identified with my body. I think I am my avatar. I have my own fears and my own, things I'm afraid of and things that keep me up at night. And so I'm no saint, and I'm no enlightened one. I'm a humble scientist that's just trying to understand what the math says. That's all. So I have no superpowers, to be very, very straightforward. I can't heal myself. I can't walk on water. None of that stuff. But the theory says that if I really let go of my identification with my avatar,
ego dissolution,
then effectively I have unlimited powers, infinite. There's, in fact, more than I can even right now imagine, because my imagination is constricted by being inside this interface a little bit. The only way to let go of that restriction is what we learn from people talking about meditation. If you let go of all concepts.
So the representation in your mind,
Yes,
all
right.
the concepts.
All of those are limitations on who you are. The only way to actually be your infinite potential is to let go of all ideas of what your potential might be. So no thoughts at all. Any concept of who you are is always going to be infinitely less than who you are.
So there is Neville Goddard, which is an English author and mystic,
Okay.
who said that you are ever sent into expression by your awareness, and your expression is ever that which you are aware of being. Could it be correct? Like, if I'm aware of being, if I conceptualize something, if I imagine it with my mind or with my feeling, can I put it into my reality?
Yes, and in some sense, everything that you're seeing right now, you're putting it there. So the whole world that you see tables and chairs, and you see the sun and the moon. Most of us think that the sun and the moon exist whether or not I looked. And what I'm saying is, no, you're putting them. You put them there. So already you're creating the sun and the moon and all that stuff. What you're doing is truly stunning. What I think you could also do eventually, but I don't know how to do that yet, would be to actually alter how you see this physical world, right? I mean, we know that there are certain ways, if you take drugs, it'll alter it, but not in ways that you can use very much.
I think about cubism,
Yeah.
the interpretation of quantum mechanics.
Yeah, quantum Bayesianism, right.
Yeah,
right.
and also the Bayesian brain.
Mhm.
And both are talking about the way that our belief about our anticipation of what's could happen can influence what is happening, actually.
That's right.
The way we conceive and believe inside strongly have impact on reality.
That's right, and that's true right now. So I see a chair there because I'm actually creating the chair. So that the chair doesn't exist until I put it there, and it's there when I create it, and it's not there when I don't create it. So yes, you're making all this stuff
Because you believe that what you feel, or you believe that it's a chair, and so you see the chair. Is it something like this?
Well, that's right. So this is now getting into the nature of our models of perception, right? And the Bayesian kinds of models of perception. That's right. Now, the way those are typically thought of, in perception that's typically thought of, is that there is a truth out there, a physical truth. And we have hypotheses in our brain about what might be out there. And we get certain amount of sensory information from our eyes, for example, and then we use Bayesian inference to infer, to guess what the real thing is. When a lot of people talk about Bayesian inference and perception, they're talking about something different. They're saying there really is a physical world out there, and it really does have a chair, but I can use Bayesian inference to accurately estimate the distance and shape of that chair. And so that's the way it typically is done. But now, in my view, the Bayesian thing is different. I'm saying there is no chair out there until you put it out there. So you're not estimating anything. There's no chair that you have to. Reality, whatever it is maybe more like the Twitterverse. It's all these interacting conscious agents that are sending experiences and receiving experiences. So like the Twitterverse. And space and time is just like a little headset that some Twitter users use to sort of grok what's trending in the Twitterverse and understand what's happening in the Twitterverse. So on that point of view, things that I see inside space and time I am creating those because I'm creating this as just a little headset to help me interact with the realm of consciousness. So in some sense, yeah, you're making the whole universe. Right now, you make the whole universe in this point of view. And so that tells you something about how powerful you are. You are creating the sun with all of its nuclear fusion.
Or making it appear.
And you're making it appear. That's right. You're making it appear. That's right. As though there was a sun. So everything that you're impressed with, I'm saying you're making it. And you're making it on the fly. You're no less than that. You should have no less respect for yourself or amazement at yourself than that. And in fact, you can never be amazed enough with who you are because your abilities are infinitely greater than what we can even see around us right now.
According to you, we can learn about these abilities?
Yes, but it's a different way than learning like going to school or reading textbooks, right? So you can learn about it. Of course, I'm a professor. I, of course, have taught many students, and I always tell you, of course, read your textbooks, go to lectures, and do your homework. And that's important knowledge. But there's a different kind of knowledge that transcends that completely, and that is what happens when you let go of everything that you've learned and everything that you know and every concept that you have and just be. That's when you get closest to the infinite power that you really are. But then when you go to put words on that, then you step back out and you get back into more headset kind of stuff, where you are the infinite, and now you're going back into this finite description realm.
How do you get into this being this infinite sensation, or the silence when you let go of the thoughts and stuff? How do you do that? Meditation? Can you do that, actually? Can you go into this realm of consciousness and being? Yes?
Yes, and I think...
How is it?
But, well, I should say first it's rare, but I can.
Rare, yeah.
Yeah. But I can say what spiritual teachers that I trust. So I'm a scientist. I'm not a spiritual teacher. But based on the science, I listened to various spiritual teachers and paid attention to the ones who what they say really squares with what the science. And what I take from that is to say that it's counterintuitive. You are that infinite intelligence, and so it's not something for you to achieve. You are already that infinite intelligence. It's a matter of, can you now, at this moment, so this is nothing you're trying to achieve. The issue is right now, can I let go of all my thoughts right now and just go into a thoughtless state? So a state where I'm just here, I'm aware, I'm alert. I can maybe close my eyes and be aware of my body and so forth. But the point is to let go of all thoughts. And you'll find that that's not easy to do. One of the easiest ways to do it is to say to yourself, I wonder what my next thought is going to be, and then wait for it. And that seems to work.
Nothing happens.
That's right. So and when I do that, I find I'm sitting there for several seconds, and there are no thoughts. And it's a wonderful space to be in.
Yeah.
So I wonder what my next thought will be. That's a wonderful way to get a sense of this. And then you're getting your first taste of what it's like to be you without the veil of concepts that is between you and yourself. So this is your own awareness being aware of itself without a veil of thoughts and perceptions in between. It's awareness of awareness directly, as opposed to awareness of physical objects, or concepts.
But if we are conscious agents, if we are these conscious experiences, can we get rid of our perceptions? Or it's different?
Well, ultimately, so this is another very deep point, and that is that my theory of conscious agents is just a theory.
Yeah.
It's just another set of concepts, right? So what am I doing here? It almost sounds like I'm contradicting myself. I'm saying that no concepts are adequate to who you are, and here I'm giving you all this wonderful stuff about this set of concepts. So what gives? And what gives is this. You do transcend any concepts. So that means you transcend my theory of conscious agents. And you infinitely transcend my theory. Infinitely. Not just a little bit, but infinitely. So what's really going on here is what we talked about a little bit earlier. For some reason, this infinite consciousness needs to look at itself through different perspectives. Maybe it just enjoys it. Maybe that's just for the fun of it. You are infinite. There's no limits. And so you have infinite exploration of all your possibilities. And maybe that's what I'm just enjoying looking at myself through this. And I'm letting myself do this, losing myself in it. So I actually think I'm just my avatar. I do that, and it looks like all sorts of nasty stuff happens. But then when I die, I'm just pulling off the headset, and I learned something. I had a good time. That's one way of thinking about it. Another might be that maybe this is the only way that the infinite intelligence can really know itself. It only can know itself in some sense through looking at an infinite number of perspectives. And so we're lost in one of those perspectives, and probably one of the simpler perspectives, frankly. That's what I was saying. This is one of the cheaper headsets that you could imagine. So my theory is not the final word. It's just a baby step, like any scientific theory. Right, right.
if I go into this realm, maybe I can have access to insights or ideas like that
Yes.
I can put into my world,
Absolutely.
intuitions and stuffs.
Yeah, if you're an artist, you could go, or a musician, you're a composer, or
We call it a flow state.
flow state. Absolutely. Of course, you have to do your homework. Again, I'm a professor. I'm always going to tell my students you need to do your homework and study. I'm not telling you to be a slacker. So do all the good stuff you're supposed to do. Learn your skills, but then learn to also be able to put it down. Step
Yeah.
away from it. Step away from everything that you've learned, and be in entire silence. That's where most of my good ideas come from. I've done my homework. For example, I haven't done my homework in playing the violin. So if you give me a violin, I can go into silence and I won't
But he
play.
isn't used to it.
I'm not used to it, and I won't produce anything but screeches on the violin. So if you don't do your homework, then it's not going to work. In the area where you've done your homework, then yes, going into the silence is where you open yourself up to your infinite intelligence. Instead of looking at reality through a little straw, you are the full-blown torrent of reality, and you get ideas. And any good ideas that have come in my research from me have not come from me. They've come through, in some sense, letting go of me. And
Your conscious you.
the conscious, that's. But the reason for doing all the homework and all the education is that then when I come back into me, I have the concepts to understand what that insight was, and I can articulate it in a certain way. So if I haven't done my homework on the violin, then I can't articulate an insight about how to play something wonderfully. Well, I don't have the tools to do it because I didn't get that set of concepts or abilities.
Last question. I have to select the one.
Sure.
What is the impact on the society and our lives
Yes.
to think this way, to go into this new paradigm in the different dimension of our lives,
Right.
and also for ourselves?
That's a great last question.
Good luck.
Yeah, well, what this point of view says is, first, it's very, very different from our standard point of view. Our standard point of view is that space and time is fundamental. You and I are little objects in space and time, and we're both competing for very limited resources in this world. And if it's going to be between me and you, then I'm going to win. I'm going to make sure that you lose. So we're in a game with limited resources, and we get competition, we get war, we get all that kind of stuff.
Mentality of lack and fear and
That's right. Fear, that's right. Lack and fear and hostility and in-group and out-group and so forth. This other point of view says, no, you are the infinite intelligence, and the other person you're interacting with is actually you, the infinite intelligence, just in a different avatar in this particular headset. So you are interacting with yourself. So treat that avatar as you would like to treat yourself. And when you actually see other people as yourself, it starts a process in which you start judging them less and less, and you start to learn to judge yourself less and less. So judging is an illusion. Judging yourself comes from the illusion that you're just this little physical object. Judging other people is an illusion. That other person is, if you know what they really are, they are transcendent intelligence. That's what they really are. What they look like is maybe a homeless drunk on a street corner.
lost in his ego stuff.
That's what they look like.
Yeah.
And we might judge them then accordingly. But in fact, what they are is the infinite intelligence exploring. That's right. So you begin to have compassion on yourself, compassion on others. And I should say at a more global level, an economic level, if we look at communism versus free enterprise economies, communism sounds really good, from each according to their ability, to each according to their needs, no ownership and so forth. And free enterprise is, more nature red in tooth and claw. We'll compete and see whoever's company is the strongest, the other one dies, and that company dies. So, communism sounds really great and free enterprise doesn't sound so good. But when we actually tested them during the 20th century, we really tested them. Communism fell flat. It horrific. And free enterprise, it's got lots of problems, but people had higher standards of living under free enterprise. What's going on here, right? Because it seems like communism is really more along the lines of what I was just talking about. Mm-hmm. Well, here's the deal. As long as we are identified with our avatars, we don't realize that your neighbor is yourself. And so if we actually all understood our neighbor is ourself, communism would be the right system. We would all cooperate, because if I'm giving stuff to you, I'm giving it to me. There wouldn't be the selfish.
Yeah, there is a condition for the communism to be right.
That's right. So communism, if we took this point of view and we really understood that my neighbor is myself, just under a different avatar, then communism would work and we wouldn't need the free enterprise system. But right now we're not that way, so I'm not advocating communism. I'll be very, very clear. Not until everybody on the planet, or a majority, recognize that their neighbor is their self, and not just say it, but actually live it. Then communism will work, but not until then.
So that would be an indication of ourselves.
That's right. When communism actually works and people are glad to help other people because they're helping themselves, and they know they're helping themselves when they help others, then we will know that state of being aware of who you really are is sort of a permanent state. Not just what happens when you go, I wonder what will happen, what my next thought will be. For that minute or that few seconds, you can be free of thoughts and start to enter this realm in which you your avatar identity.
And you go into love. You're talking about love.
That's right. Exactly.
Loving each other.
That's right. That's actually, you're loving each other because you realize that the other is yourself, so you're loving yourself.
It's all about love.
Yes.
I like to think this way.
Yeah. The bottom line is that love just means recognizing that the other is yourself.
Yeah. Fantastic. Thank you so much, Don.
Thank you very much, Sarah.
I hope you are going to have new insights and that you are going forward with your theory, because I think we should learn about it, about being conscious and stuff. So thank you.
Thank you very much.
Yes. Bye.
If this content resonated with you, don't leave without liking, sharing, and subscribing. It's free, and it really helps support the channel and spread these powerful ideas to more people. Thank you all, and see you soon on the next episode of Super Sapiens.